Welcome to Geekloka Technology Tutorial. In this video, we will learn about insertion sort algorithm. Let's get started. Insertion sort is efficient for small datasets and works similarly to the way you sort playing cards in your hands. Let's see how this works with an example. Consider the array 60, 10, 70, 40, 20, 90, 80, and 50. Our goal is to sort this array in ascending order using the insertion sort method. The key idea of insertion sort is to divide the array into a sorted and unsorted section. We start by assuming that the first element is already sorted. Then we take the next element and insert it into the correct position within the sorted section. This process is repeated for all elements. We start with the index 1, which is 10. We take 10 and compare it with 60. Since 10 is smaller, we insert 10 before 60. Our array now looks like 10, 60, 70, 40, 20, 90, 80, and 50. Next, we consider 70. Compared to the already sorted elements, 70 is larger than both, so it stays in its position. The sorted part now is 10, 60, and 70. We continue this process with the next element 40. We compare it with 70, then 60, and insert it before 60. Our array becomes 10, 40, 60, 70, 20, 90, 80, and 50. We repeat these steps for each element, inserting 20, then 90, 80, and finally 50 into their correct positions. With each iteration, the sorted section grows and the unsorted section shrinks. We compare 20 with the sorted elements. First, it's compared with 70, then 60, 40, and finally 10. We find that 20 should be placed right after 10, so our array becomes 10, 20, 40, 60, 70, 90, 80, and 50. Next, we look at 90. Since 90 is larger than all the elements in the sorted section, it remains its position. The sorted part now is 10, 20, 40, 60, 70, and 90. Then, we take element 80. We compare it with 90 and find that it should go before 90. So, it's inserted between 70 and 90. Our array updates to 10, 20, 40, 60, 70, 80, 90, and 50. Finally, we have the element 50. This is compared sequentially with 90, 80, 70, 60, 40, 20, and placed between 40 and 60. After sorting all elements, our final array is 10, 20, 40, 50, 60, 70, 80, and 90. This is how insertion sort works. It's efficient for small arrays and easy to implement. Now we are going to walk through a sample code for the insertion sort algorithm. Let's dive into the code and understand how it works. We start with a function named sort, designed to sort an array of integers. It takes one parameter, a RR, which is the array we want to sort. Inside the function, the first thing we do is determine the length of the array with array length. This tells us how many elements are in the array and hence how many times our sorting loop should run. The sorting process begins with a for loop. This loop starts from index 1, not 0, because we consider the first element as already sorted. The loop continues until it has processed each element in the array. In each iteration of the loop, we select the element at current index I. This element stored in temp is the one we are going to insert into the sorted part of the array. Now we need to find the right position for temp in the already sorted section of the array. To do this, we use a while loop that continues as long as j is not negative and the element at array index j is greater than temp. If the condition of the while loop is true, it means array index j is greater than our temp value and should be moved one position ahead. This is done by array index j plus 1 assigned by array index j. We then decrease j to continue the comparison with the previous element. When we find the correct position for temp or reach the beginning of the array, we exit the while loop. We then insert temp into its correct position with array index j plus 1 assigned by temp value. The outer for loop then moves to the next elements, and the process repeats until the entire array is shorted. In conclusion, insertion sort is great algorithm for small to medium size arrays. It's simple and has an average and worst case time complexity of O(n squared), but performs well with nearly shorted data. Thank you for your attention, and I hope this video helped you understand the insertion sort algorithm. This is the end of this video. Thank you for watching Geekloka channel. Don't forget to subscribe and see you on next tutorial.